Thank you very much for your invitation and also introduction. And I'm Sun Zhe, and currently I'm working in Zhongdendo University as a lecturer. So today it's a great pleasure to introduce the system of NeuroLibre server in Japan, in Zhongdendo. Also, some our current project related to the neural the digital brain or brain or MRI processing. So let me firstly briefly and introduce the timeline to establish this NeuroLibre Japan node. So actually in this year, in March, and Professor Fugaku came to our university and we started to discuss about how to establish a NeuroLibre server in Japan. And from the in June, and we got organized the network in Zhongdendo University, and in July we prepared the server, and so we had some security problem in July, but we solved, and just 1 day ago, and we connected the server with the global IP. So from here, from Canada, and you can from yesterday, and you can access our server. And also today I will give you briefly introduction for the server. So where is the server? And as August already introduced, that our institution is in the not in our hospital, and also the faculty of the medicine is in the center of Tokyo, but actually for our department, the faculty of data science is in the campus of the called Urayasu Hinode campus. Hinode means the sunrise and in Japanese. So for this, I think it's also a good, because the sunrise means also starting or beginning of the beginning. So I think it's a good start or beginning for our collaborations. And also this campus, this Hinode campus belongs to the Tokyo Disney Resort. So it's very easy to remember that when the server was established, it's yesterday and just before the NeuroLibre Day. And where is it? It's in the Tokyo Disneyland Resort. So so in June, and we started to establish a network for the MRI processing and also for digital brain project in Zhongdendo University. And here you can see that we have such a kind of the complex network. This network complex has 3 features. One feature is that we are using the SciNet 6, which is the fastest network in the Japan. It's more than 40 giga bandwidth, and it can transfer the data very quickly. And also the network connected to our database, and we have currently have the Zhongdendo database and the JMate database, and also some other database like Biobank, UK Biobank, which is has a more than 60, I think it's 60,000 patients or health control data, and inside the database we have a write system to contain all of the 6 database. And moreover, and we can access 3 supercomputer systems in Japan. One is the Fugaku supercomputer. Fugaku means the Fuji mountain, and which is 2 years ago it was the fastest supercomputer system in the world, but now it's the fastest supercomputer system in Japan. And also we have a Foxeye, which is using the Intel CPU. It's a big, also a very powerful supercomputer system. Also, we have the writing system. Writing system is using GPU, which we can train using the MRI data to train a generative MRI deep learning model. So here it's an updated version of the network. You can see that between the SciNet and also the internet, we prepared the Japan NeuroLibre Japan node is like this. Now, the Canada side and Montreal side can access this Japan node by the global IP. And also here is our two members in my lab who is managing the system. In the behind of them, it's that node. I want to introduce a little more about our current project, which we would like to contribute for the NeuroLibre system. And firstly, it's that because now we have a GMID database, also we are using the UK Biobank database, which include a lot of the neural imaging data. And actually, you know that for the pre-processing or processing the data, it takes a lot of time. But we have the access. We have a lot of the results from the supercomputer center. So in the past half year, and we compare all of the software for the MRI processing, the neural imaging processing in supercomputer system. And we succeed in both of the Hokusai system, which is using Intel CPU, and also the Fugaku system, which is using a Japanese-made CPU system. And this include especially the Fugaku, which has more than it's like 150,000 CPUs. And
imaging database become
in that case, and we can process a lot of the data and the patients simultaneously. For example, for Hokusai system, we can for 6 hours we can process more than around 5,000 subjects data, and for Fugaku system, we can process more than 476,000 subjects in the around 10 hours. So it's a very powerful system. And also, we are not only using the supercomputer for the data processing. We actually from this September, we joined that BrainMantis project, which is the biggest national brain project in Japan. And so this project, so in the past 10 years, we already collect a lot of data from human, from the mammal side, from monkey, also from mouse, and we organize a big database, and now you can download from the homepage. And in the next 10 years, and from this month, in the next 10 years, we are not trying only to investigate the brain network from the data. We are also trying to construct a brain simulation, and we call the Digital Brain Project Plan. In this plan, and we want to organize all of the structured data, and also we are trying to build a SNN builder, it's a brain builder system, and on the Fugaku supercomputer, and then we will get the activities, and we want to compare with the simulation, the digital brain activity with the realistic brain activities. So now we are currently using diffusion MRI to simulation the brain. After that, we will get the EEG signal and also the fMRI signal, the activity signals from the simulation system. We want to compare this from the virtual brain, digital brain, and the realistic brain. So from now and we would like to discuss much more collaborations with the NeuroLibre, not only on the MRI data processing but also on the brain modeling, because if we have much more data from the structure, we can also provide some script to make a digital brain in the server. So that's I hope we can establish in the future work. Thank you very much.